Okay, 4.02, I can write equations of upper and lower bounds and use them to create a range of predictions. Using your Desmos graph from the previous problem, find the equation of the upper bound, the lower bound, and then use your least squares regression line and upper and lower bound equations to predict the score of someone that studied for 4.4 hours and provide a range of scores. Provide your answer in a complete sentence. All right, so let's go back. So I've got my equation here, all right, and I've got my residuals. So if you haven't plotted your residuals, you don't have this column, you will have this right here. There'll be a gray button that says plot. You will click on that and magically you will get your residuals. And essentially your residuals are just what the expected value is and what the data point was. Okay, so I've got my residuals. Okay, there they are. So notice they're also plotted down here, right? Because we also plot the residuals down along the x-axis. So what we're looking for is the largest positive residual and the absolute value of the residual, the largest absolute value of the negative, most negative of residuals. Sorry, that doesn't make sense. Just look for the smallest number. So the smallest one here is this negative 6.32, and you can tell that it's right. Is it that one? Yeah. Okay, that one's the furthest below the x-axis. And then the one with the highest, furthest away on top, I believe is going to be that one, 2.772. So let's look if there's one bigger than that. There is not. Okay. So what we're essentially going to do is we're going to draw lines that go through these points up here. So this one here is this data point. So I want a line that is parallel to my least squares regression line that goes through this point. And that's going to be my upper bound. And then I'm going to take this point and I'm going to draw a line that's parallel to my least squares regression line that goes through that point. And those are going to be my upper and lower bounds. All right, so how do I do that? Well, essentially, I just take the line that I already have, which is right here, right? Y equals 7.67x. I have the plus 48.49, and I'm going to add the 2.77, and that's going to create this line that's 2.77 units above the green line, and notice it goes through that point that had the largest residual. Okay, then I'm going to do y equals 7.67x plus 48.49, the original line, but then I need to subtract that negative, or the 6.32, right? So minus 6.32. And there's that line that's parallel to the least squares regression line, and it's going through the data point that's the furthest away below the least squares regression line. All right. I don't want you to write your equation like this. I actually want you to calculate 48.49 minus 6.32 and 48.49 plus 2.72. And if you actually go through there and calculate those, this number becomes 51.26. And 48 minus the 6 there is 42.17. Okay? Upper bound, lower bound, expected value. So remember, the question actually asked me to predict the score of someone that studied for 4.4 hours and provide a range of scores. Provide your answer in a complete sentence. So if somebody studied for 4.4 hours, there's this blue line. Let's find these data points. You would expect them to score an 82. On the low end, you could expect a 76. And on the high end, let's see, you would expect, oops, I need 4.4 to show up. Let's zoom in so I can get to it. There we go, 4.4. On the high end, you would expect an 85. So let's click on all those now that I'm zoomed in. 76, an 82, and 85. Okay? So how do we write that? Well, let's take a look at what I did. All right. I have my equation of the upper bound. I have the equation of the lower bound, right? I put in 4.4 into my Desmos model. I got an output on the upper bound of an 85. The expected value was an 82, and the lower bound was a 76. Right, just to double check, right? 76, 82, 85. So here's my sentence. If someone studied for 4.4 hours, based on the data, I would expect them to score between 76 and 85 on a test with an expected score of 82.